Hi, in this video I'm going to show you inheritance. So first we will uh, basically we made a book. We gave it a name string, we gave it a double price, we gave it an integer rating, we gave it a boolean if it's ripped. And now I go book b1 equals new book, and we have a new book. I'm gonna write b1 dot, we have name, we have price, we have rating, and we have ripped. That's a boolean. Now I'm gonna make a new class. I'm gonna do the same thing. I'm gonna call this one disk. And this disk is a disk and it has the same thing. So I'm gonna go and copy and paste. I don't want to copy and paste ripped because a disk doesn't get ripped. Do the same thing. Instead, I'm going to create a new property by writing prop tab tab, and I'm going to name this as a boolean, and this boolean is going to be named scratched. So yeah, whatever. We name this also name big P, price, rating, and ripped. So we have here all these variables over here. I'm writing here b1 dot, and you have your name, price, rating, and ripped. And the same thing if I do with making a new disk d1 equals new disk. Whoa. Equals new disk. And I'm gonna write d1, and it's gonna have the property name, price, rating, scratched. So I can name if it's scratched, what the condition is, all the thing. Is it? So what I want to do is make a thing called inheritance. Why would I go copy and paste? Let's say I want to do a new one called a laptop or maybe a computer. Make a class. Computer. So I have over here a class called a computer. Now I have to go again and copy paste all these stuff and add new properties to it. Maybe write what kind of computer it is, maybe the description, maybe I'll have a new one called prop speed, computer speed. So I'm gonna have decimal, maybe a double, and it's gonna be speed. So you get it. And I'm gonna make a new computer, but I don't want to just copy and paste every time stuff over and over after I create a new product. So you get what I mean. So I'm gonna make a more efficient way by just deleting everything here, deleting out all the stuff that have in common. So what has in common? Name, price, and rating. You see, this has name, price, and rating. This has name, price, and rating. So I'll just go and delete out from the computer class name, price, and rating. Do the same thing with the book class. And I'm going to make a new class over here. I'm going to call this class product, because every product has a name, a price, and a rating, what people want to give it, how good or bad it is. So I'm going to write product. Class product. Class product. And I'm having this product. I'm just going to copy and paste. Just take this out of here. Control X. And name. So now I'm going to go to the book class. And you see over here, the book only has a property ripped. And when I go, I write D1, B1 as the book. Just delete this disk out of here. B1 dot. You see over here only a property ripped. All these properties aren't, they're inherited from all these properties. You see over here this small tool over here, that means it's a property from my class, and it says over here ripped. So you can only assign if the book is ripped, but the book doesn't have a price in the class. So b1 dot, I can write b1 dot price and equals it to 15, and it's going to give me error. Does not contain a definition price and no extension method price accepting a first argument of program book. It gives you basically a whole thing that there's no such property as price. So what I do is I have to do a thing called inheritance. I say this book, what is it? It's a product. And what is a product? A product are all name, price, and rating. So I'm going to write product, and when you go back over here, it still gives me an error because, yeah, I think so. I wrote price with uppercase. I don't remember, but I'll use IntelliSense, this special thing that C# has in its IDE. So now you see name, price, rating, and ripped. You see now 4 properties. Why? Because name, price, and rating are inherited, but ripped is in its regular class. The same thing I could do with, I'll go to computer. I'm going to make a new computer. Computer C1 equals new computer. Alright, C1, done. And you see only here, only speed. What I'm going to do is I'm going to hook it up to the inheritance. Make computer also inherits from product. So I'm going to write product. So now the same thing, it's getting a name, a price, and a rating. And the same thing I'll do with a disk. I'm going to inherit it from product. And they should all be inherited. So now I go, now I write C1, and it has name, price, rating, and speed. Now I want to have some more fun. So I'm going to do a thing that's going to inherit from a child class. This is the base class, the up class, the top class, I think so it's called. A base class. It's a base. It's the top class. It's called a base class. You could call the base class. You can do a lot of tricks by calling. I'll go into it later on. I don't think it's necessary even now. Like right over here, base dot. No, it's not working. I don't remember how to do it. Whatever. So I have to look that up on Stack Overflow maybe. I don't know. That is not working now. Computer base. Yeah. Yeah, we call the methods from this. You have to write override, I think so. Virtual. Yeah, virtual, I think so. So I gotta write here. Virtual. Here. Here I'm gonna go base. Maybe override. Override. Yeah, here I have it. Name. I could override the name. So basically, if this had a name here, and it was equals to default to AAAA. Well, because equals to AAAA. Why is it giving me error? Name is equals to AAA. Why would it give me error? I don't know. This is strange. Why? Maybe it doesn't have getters and setters? I don't know. Don't know. I don't know exactly. Why is this giving me error? So basically you could write override name. I could write name, and you write over here get base. Oh, yeah, whatever. So I'm not gonna go into this. It's not for now really. All right, name, and it overrides the upper class over here. It's basically I want to do this get and set. Maybe I have to get and set from the base. Yeah. Set base to equals value. So instead of writing values the if they instantiate it, the value becomes to the value that you made equals to the setter. I'm not gonna go into get and set. It's not for now, but you could do with this thing. I could write I could write hello, and I'm automatically setting the base class as name to hello. So basically the disk's name is going to be hello, the book's name is going to be hello, and the computer's name is going to be hello, because I didn't set the property to this computer name. I basically called the parent and tell the parent that all the childs will be called by that name. So I could write it over here. Maybe I could even test it and show you. Maybe I'll go to write book. So I'm gonna write CW tab and B1 dot name. I'm gonna write console.read. By the way, I think I never did this one, but it should work through my understanding. So this is the first time I'm doing this. B1 dot name. No, console.read line. What am I doing? Console.read. And it's just slowing down me. It looks like the name doesn't have any value. No, I was wrong on that. The name doesn't have a value. Let's debug this one. I'm just gonna debug this one for a second. Book equals new book. Yeah, no, it doesn't carry anything, so I was wrong on that one. I was literally wrong on that one. Just, how do you shut this? Escape, no? Just maybe F5? How do you get out of here? Yeah. Maybe enter, yeah, enter. So, the base class doesn't, it only, I saw right now, see, out of debugging, not even knowing what I'm doing, that the computer, when I'm writing base.name, it's basically changing the property that's overriding only to the computer class, and it's not calling to the parent onto the other classes. That's what I just saw. So basically, if I, what was it that I changed it on the computer? So if I go and write C1, changes to C as the computer, it is going to show the name, if I'm right, that it changes only to that item of the inheritance. And dingo, did not write it. Why not? Override string return base.name. If I set this base.name, it should return the base.name. It's just not. Set base.name to hello. And it should return the base.name. Do debug again. And it's not giving me anything. I'll just come back in next tutorial and show you the whole virtual override. So it's not for now. I don't know what I'm doing wrong. Doing something wrong, but I don't know exactly what now, because I didn't really ever use it. So basically I'm having over here the disk, the book, and the computer. Now I want to make a new class. I'm going to call this class laptop. A laptop is going to inherit from computer. So the laptop is inheriting from computer that the computer is inheriting from the product. So I'm writing over here laptop. Correct. Laptop L1 equals new laptop. Right over here L1 dot have name, price, rating, speed. But a laptop folds, so I'm gonna make here another thing. I'm gonna call this, if it's a foldable laptop, maybe it's not foldable. Oh, battery would be a good idea. So I'm gonna write double because it's a number, so I want to give it a double, and maybe an integer. Yeah, integer. Battery. battery. A computer doesn't have a battery. So this derives from a computer. And maybe I want to make it as a property. Make it just with getters and setters. And I'm going to call it battery. And I have over here an integer. Why is it playing this? Whatever. Okay, so public integer battery. And I'm over here laptop L1 dot. And I have battery. It has a name. It has a price. It has a rating. And it has a speed. So it has everything that a computer needs to have. So let's give it some property. Let's give it a name. Give it a name equals to Lenovo. And I'm gonna go over here L1 price. $1,009 L1 dot. We gave it a name, we gave it a price, a rating. We give it 4 stars. L1 speed. So it's 2.4 gigahertz. And L1 battery. So the company ships the battery filled with 100% battery power. So the second you order the battery, you don't even need to charge your laptop. How great is that? So you have 100% battery power. So no need to worry. And now here I'm gonna do a small thing in the product. I'm gonna write here override. Why am I doing this? Override toString returns to the base. That's the upper base, not this base. So it's the base. It's calling the class that's above the product class, because every class inherits from system.object. I'm gonna go into here, and I could go go to implementation. No, not really. Not go to implementation. Yeah. Peak definition. And here, not peak definition. I don't know what it is. I'm tired today. Over here, I think so. Yeah, it's this one. Go to definition. Yeah. I think so. Let's go to implementation. I don't know. It doesn't work on this, maybe. I don't know. So every class inherits from a thing called a system.object. So here I'm overriding the thing called a toString method. And that's virtual over there. It's basically lets you override the toString method that comes. Yeah, you see over here it says base class system.object supports all classes in the .NET Framework class hierarchy and provides lower-level service to derived classes that are derived from the system.object class. This is the ultimate base class of all the classes in the .NET Framework. It is the root of the type of the hierarchy. So basically, the IDE of Visual Studio is nice enough to tell you that everything inherits from the system.object. Maybe I could go click on base, and maybe it will take you to the base class by There, yeah, and boom. Here I have it. See, this is what I was looking for. I had to click on the base to send me to the base class, not to the class itself. So here you have the whole metadata of everything that every object inherits automatically without you knowing. So here you have class.object, and here I never did this, but I should be seeing the property toString. And here you have it, public virtual toString. So a string that represents the current object. So the string represents the current object. When you call the .toString, it's gonna show you the class of the name of the base class automatically. So I'm gonna go here and I'm not gonna override it. I'm just gonna comment this out for now. And if I'm gonna write over here console dot write CW, and I'm gonna write over here L1. It's gonna give you a name of my child class. It's gonna tell me system.object.laptop, and I want to give a console.read. Read line. I'm gonna go over here. Should give me the console.application. Why do I have to click on the enter button? Oh, that's the reason why all these bugs happened. I had over here a console.read line, so it automatically gave me nothing. So everything that I was showing you over here, why it did not work, and this whole virtual override was supposed to work, I just had this small bug over here that was just driving me nuts. I forgot a console.read line that was up over here that made all these problems happen. And I'll show you maybe in next video how the whole virtual override works. I was just not figuring it out why it's not working. So yeah, I have console application program plus laptop. Basically tells me that this is laptop inheriting from program. I'm a laptop. Basically L1 is a laptop that inherits from program, and this is the console application. So that's what the toString method and that class writes to you, but I'm gonna do an override on it. I don't want that the toString method, so automatically when I call L1 as a laptop, it defaultly gives me the toString method. So what if I want to call the name? So I could write L1.name, and I'm gonna get the name, and I have Lenovo. And the same thing I write over here, L1.speed, and the same thing, 2.4. And I could go L1.toString, because toString is from object.toString that comes from system.object. It's going to be essentially the same thing as calling L1 by itself. The same thing. It's automatically in C# that the toString method gets called automatically. So you don't need to call the .toString method. So you could write L1 and it's going to call toString method. So it automatically calls its constructor that gets the toString. So I'm going to do an override on the toString method, and it's going to call the base. I'm going to override the base class, override toString, because remember that toString was virtual, and I'm going to return here the base. Instead of returning base.toString, it's the same thing as doing nothing basically. It's just doing the same redundancy. I'm just going to take this away. I don't want to return the base.toString. I want to make my own toString. So I don't think I should do it here, because yeah, it makes some issues if I do it in this class. I just got this one. It would be better if I create it in my laptop class by itself, because I don't want to my laptop class only print out this. I want to print out all of them. That's battery included also. So I want to do it in this class. Same thing. Override. I'm going to just copy and paste it. And instead of returning base.toString, I'm going to be returning CW. I'm going to be returning. I'm not going to be returning anything. I'm going to write void if it lets me. Return type must be string to match the overwritten member. Okay, looks like it has an interface or something that restricts me from doing this. I haven't looked into the base class, but it just restricts me. I have to return a string. It has to. So, but I'm gonna, yeah, of course it needs to return a string. What am I thinking about? Of course it needs to return a string. It returns a string, and then it's gonna take that string and it's gonna pull the method and it's gonna show it to my console. Now, it is not working. It's now almost at 12 o'clock, and I want to get this tutorial done. So I'm gonna do return a string. So let's make a string. I'm just gonna I have to write here string. Yeah. So I'm gonna write here the string that I want to return. So what am I gonna return? I'm gonna return all the properties that it inherits plus the property that is in this class. So I'm gonna go here and I'm gonna call some interesting overload. Alright, string dot overload. I think so. String has a property called overload, not a property, a method. I think so. It's not this string object. I think so. It's the string. What's it called? The string static. The static. Going into the static string. So I'm gonna go string format. I think so. Yeah, here it is. It's in the other string class. So I'm going his string, and it has a lot of overloaded 4 overloads that I could do with this. So I'm gonna write here string the format, and 1, 2, 3. So how many does this have? Name, price, rating, and it has a battery also. So I'm gonna make a 4th one. I'm gonna write here 0. So so I have to write here this way. It gets overloaded, and somewhat like this. Yeah. So I'm gonna write here, yeah, 0, 1, and the same thing here, 2. Here I'm gonna write 3. And I'm gonna do all the properties. So I'm gonna write this. I think so. This, yeah, this. This. I'm referring to this class. This works on inheritance. Yeah, it does work on inherit stuff. because it's like in the same class. So I'm gonna write here name. I never did this before. This whole, I don't know why I would want to inherit. I use interfaces, but yeah, I just want to show you inheritance. So price, this. You don't have to write this, but I like to write this. It's more clarifying. Dot rating. Dot. Oh. I need to put this. So do the same thing again. 1, 2, 3. And I think so. The last one is the battery. And there we go. To write battery, I want to write this. It's the same thing. Just this, the battery, and it's referring to this instance of the inherited class. So it's all the mistakes basically that I had in this video wasn't real mistakes, because I just had that bug over here that I just couldn't, I don't know, whatever. This was like so much over here going on. Normally in regular development you wouldn't be creating all these classes. You would have one guy creating all these base classes and all this stuff, and you wouldn't touch them. You wouldn't touch them for your dear life. And then you would have, you at the lower level would basically take in this whole thing as a DLL and basically using these classes as an abstract, and you wouldn't be able to touch it or override it, only what they let you. And they would make it proof, like put a lock on it. You shouldn't be able to do anything, just to use it. And if you don't know how to use it, you would have to go to that team and say, hey, how do you use those objects? What do you do? Why did you change the laptop class yesterday? Why did you change that class? My code is broken, and what do you do? And that happens a lot of times in companies, and that's why a lot of companies don't use inheritance. I know a lot of companies that don't use inheritance. They use interfaces because it's more clarifying. And then you have a lot of companies arguing you should use inheritance, and everybody has their own opinions on what you should use and what you don't use. And yeah, so I'm gonna write here L1, and it should print out everything, but I want to do it nicely. I want to make a plus, not a plus sign, maybe an equal sign in between, make it look nicer. Yeah, and koala, Lenovo 1009-400. Hey, I didn't write, I could write like this. Always forget this. Name, alright, name, and price, and rating, and I just want to finish this tutorial already. Battery, and let's compile it again, and voila, we have name is Lenovo, price is, well, this is confusing over here. This is just confusing. Let's take away the equals. Let's just make it spread out. I think so. This is gonna keep it. Not spread out over here. Spread out over here. Maybe this is gonna be neater. Maybe I should write the /n to make it on different lines. Do that also. Just don't have nerves to type now. And this should be nice. Yeah, name Lenovo, price is 1009, rating is 4, and then you have the battery is 100. And of course you could do this all with all the objects and all the inheritance, all the stuff. I just don't want to, just tired. Just keep it as this. And if you like it, please subscribe.